everyone, thank you for tuning in. So to do a simple tutorial on how to detect face mask using Intel's OpenVINO toolkit, and let's quickly check it out. Decided to go ahead and created a face mask directory, and in this directory I have resources. Pretty much these are just videos containing people displaying face masks and so on and so forth. Let me just quickly show you a simple video. This is just a simple video of a lady wearing a cotton mask. So this tutorial works both on cotton mask and your normal respiratory N95s and so on. Also, I have an inference script. I decided not to code this. This will be available on GitHub. Pretty much this is just an OpenVINO network inference engine that I have working, and just a simple walkthrough. There's a class network here. I just load in the model, XML models. I'll show you how to generate all those. And here I'm just getting the input shape of those models. This is just the execution of the models, and pretty much a wait to just check if the inference request is requested, and out I get my output. So first of all, we're going to need two models, one for detecting the face and one for detecting the face mask. I decided not to train the models from scratch. That is time consuming, which I don't have. There's already pre-built models that one can use either by just Googling searching and or going to the Intel Model Zoo. There is one that I found, face detection aiders, which uses mobile nets, and as you can see the results, it's promising to give us above 80%, which is pretty much reasonable. And there's a Caffe model, so we're gonna download it, and as you can see, these are some of the remarks that are very important to note. The number of channels, which is BGR, and the height and the width. Also, one thing to note is the outputs. These are going to be useful when we are plotting our triangle around the face. And also, the model that I found was on DD mask detection. This is pretty much a basic model. All the other stuff has been removed from it. It's the output that you get. It's either a 1 or a 0, which simply means either a mask or mask off. This is very useful. The model, it's Caffe, and there it is. So we're gonna pretty much download these two models and convert them using a model optimizer or OpenVINO model. So for the Intel model, I already have a Docker container that I use. Since I'm using Ubuntu 2004, it doesn't have full support for Intel OpenVINO at the moment. So for this, I'm gonna use the model downloader, which pretty much takes in these arguments. But for me, I need the name. There's the name and the precision. Let's do floating point 16. Quickly download while that downloads. Okay, it's good. So it downloaded our model. This is our model. I love these models because their sizes are pretty much reasonable. I mean, 2 megabytes for a model. If I was using a single shot detector, it would probably be over 100 megs, but this one are much more suitable. And so we're done with downloading our face detection models. Now we need to download mask detection, and just create a directory and move my model in here. Models are called the intermediate representative. They're gonna be used on OpenVINO toolkit. So let's just quickly go and download DD's model. Just find it quickly. Copy and paste. Pronto text and actual white Caffe model. Just download that quickly. Let me just pause this for now, and again as it downloads, let me just pause this for now, and so since we're done downloading the Caffe model for the face mask, we're gonna need to convert this to intermediate representations so that we can use it on Intel OpenVINO. And for this, I'm gonna show you how to download this, convert this. So there's a nice helper for pretty much model optimizer. So for this, it's gonna be Caffe. So framework, it's gonna be Caffe. And title Caffe. So Caffe takes in an input, so input model. In this case, it's what is it? The Face Mask Detection and input proto. This is gonna take a little while to convert. So optimize it, and we have Intel OpenVINO intermediate representations. So there's our face detection and our face mask detection. So we can just clean this. Have a script that will take in those two models and probably either an input either from our webcam or from the resources, which is an MP4 video, and then it will do the inference and pretty much draw a bounding box around the face, showing that the face has a mask and the face doesn't have a mask. I want to call my script face mask detection, and this should take in face model, which should be in models, face detection XML, and mask detection models, it should be face mask XML, and our input video, input, let's take in resources, mask video. Cool. So since this doesn't exist, so that's pretty much how it should work. And let's start making our script. So first of all, it's always good to import time when needed, and argument parser from arc parser, import argument parser, and definitely we're gonna need CV2 because we're dealing with processing, and we need to import our module that we have created. Import network, right? And since we want to pass in arguments, we need to define a parser, and a parser is the instantiate parser, argument parser, yeah, add arguments, so parser dot add arguments from, and we need 1, 2, 3, 4. So this one will be our face model, our mask model, media input, and yeah, obviously these are required. By default, this should be required, right? Because what's the whole point? And those for the help, I'm gonna fix it later. All these are required. So we need to return parser dot parser yeah, I'll clean it up. Give me a sec. I'll just clean it up. A few arguments on the argument parser and a few more details. One that I added was debug. So yeah, I have a main function. So in here we're gonna call in our arg parser, and we need to pass these arguments into our inference for the stream. Let's just call that infer on stream. So this will be the inference on stream, and we'll take in arguments. And yeah, so we need to define this new function. So this function will pretty much do the whole shebang, and this takes in arguments. And for now, first of all, we need to initiate the face mask inference network, and also the face detection inference network. We already imported that network, and we're gonna just duplicate this for the mask detection. And for our we didn't have a probability. Maybe just add probability as well. So probability, it's not required. That's a string, and defaults to 0.8, because as we saw with the model, it's minimum 80%. So probability, yeah, blah blah blah. I'll fix that. So in here, probability threshold. And to load in our models that we have, of which this load model takes in that, then defaults to CPU since we need any CPU extensions. So this takes in the model XML, assuming that it's in the same directory as the binary file. Here I'm just splitting the end of the file and appending .bin, checking if the file exists, and checking the model size. This is useful later on when you're doing probable statistics. So I'm having an exception here, catching an exception, because depending on the version of your Intel OpenVINO, the implementation is different. But for the current 2020 version that I have on my Docker container, it uses this part. So in here I've defined my inference engine core, which is there, and I'm reading the network and saving it to the network. So in here it's going to be that. Also I need one for the face. Add our model, this model, and done. Next, you need to start up, not really start opening up stream, but we need to decide which stream we're using. And we mentioned that there's two possibilities. There's either the camera or the video. So for this, let's firstly have the check. And firstly have a check to check if this is a camera input, and if it's a camera input, we pass in 0, alt, and the video file will be input. And it's always advisable to always just double check if there's an actual file or not. You all know. I'm not sure if I imported OS. Alright, so now there's where that's being found. So let's define our stream. CV2, this is our streaming capture. There's video capture, and the video file that we defined. And now we need to open up the stream for that video file. But also the other one thing that we need to do is we need to check the input. So we need to grab the shape of the input, and in order to do that, we'll just call it original width and original height. And this will be an integer and stream, and let's get per index, index 3, index 4. Now we need to get the input shape, the one I showed you. Where is that? To get the input shape, the one I showed you here. So that's the input shape. We're gonna need that for our inference. And since this thing returns 4 outputs, we don't care about the first ones. So let's do input height and input width. Can't even type anymore. So this for the face front network, and we get input shape. And let's do the same for our mask. And mask. So just a walk through. This pretty much just returns the input shape of that input blob. And yeah, simple. Yes. As a check, we would need to raise an error if our stream is not opened. It's not opened, and need to have a message saying cannot open video or video source. Let's make my message. Cool. So so far we've defined our network. So we've got 2 networks for the face and the mask. Probability thresholds. We've loaded both our models for the face and the mask. We've decided which capture we're using, either the file or the webcam, and we've started our stream. We've defined our original height and width our video and our model inputs, and if the stream is running or not. And now we need to read the stream, and the best way to do that is to only read while the stream is open and grab first frame is open. You need to read the file until the stream has been closed, and in order to do that we need to read it forever until the file is pretty much closed. And we need to grab a single frame. We need to grab that frame, assign it to, well, it returns a tuple, of which the first one it's an integer and the other one it's the actual readed values. So the other thing that we also need to check, we need to check if the frame was not grabbed. Then we might have reached the end of the frame, and then we just need to break out of the loop. So we need to process our frames. The best way to do, we have two models, one for the face and one for the mask. They both have different inputs, so the best way would be to process them separately. So in here, let's start a new function called process frame, which will take the frame that was read, the input height, and this of the have different inputs width and height, so they need to also be processed differently. So in this case, we have mask inputs and with inputs. Define it just up here, and our function takes in 3 arguments. It takes in frame, it takes in the height, and it takes in the width. And what it does, the processed frame, and it needs to return a processed frame. Right, cool. And here we need to resize it to fit in model. In this case, let's see, we wanted to resize it to these values for the different models. So in here we use CV2 and we call it resize. We're resizing the frame and the width and height. And then since this starts with height and width, and we call this as width and height, we need to transpose such that the height comes before the width as shown on this shape here. So in this shape we've got a batch, we've got the number of channels, and we've got the height and the width. So in order to do that, we need the process frame and transpose this, and we're taking the height width channel and transposing it to channel height width. Yes. And we need to add the batch size. And to do that, we need to reshape it such that we add that one and pass in the pre-frame shape. Right, so that's done. And so we resize, we transpose, and then we reshape. Here look pretty much something like this, with batch size, channel height, and width. Yes. After processing the frame, we've got the process frame and the mask process frame. Now we need to execute our inference from those two frames, and in order to do that, we pass it through our network. And the way we do that, we need to execute the network and pass it the frame, basically what's happening. So we make an asynchronous inference request. Since we only doing one thing here, a single inference, we passing it a request ID of 0, getting the blob and passing the image. So this does asynchronous. So we're gonna have to do the same also for the face, for the mask, and pretty much copy and paste. So after it has done its inference, now we need to wait and check if the status of the inference request, right? And in order to do that, to face wait. So this will return an integer, but we need to wait for both the face and the mask. Besides that, we don't have to waste so much resources and time. So maybe the same, copy and paste. I'm sure there's an efficient way of doing this, but this kind of like works. So after the inference has been processed, well, to extract the output. So let's just call this the result, face results. And the face inference, we need to get the output. Right, we need to do the same also for the face, for the mask. Get the output. Now we got our outputs. We need to draw a bounding box, and we need to get the output of the frame from the bounding box. In here, the bounding box hasn't been defined, so might as well go and define it. Bounding box, which takes in the frame, the actual frame, the results from the inference, and the F results for the face, and the results for the mask, right? And our threshold, probability threshold that we defined up there. The original width, this is going to help with the bounding boxes creation. So original height, and as always we haven't defined this, we might as well define it. We're going to put it here and define. Yeah, and as we said, this takes in all those inputs. Don't want to type them all, just paste. Right, just clean up a bit. Mentioned in the docs, it says that the network output blobs with the shape of this array 1, 1, 1, n, and where n is the number of the detected bounding box. So in order for us to find that we know that gonna be like this, so 1, 1, and 7. So our face results would look something like this, where we only care about the nth element. Right, so in here let's say 4 box in that list, and we know that the confidence it's index number 2. So here is going to be confidence box index 2, and obviously we can't just plot the bounding boxes for everything. We defined a threshold initially, of which the threshold was 0.8, I think. Yeah, 0.8. So now we only care about the outputs that are greater than the defined probability. And as shown here, the coordinates for top left and top right bounding blocks, let's call this x min and y min, and y max and x max, all those equals to an integer because we don't want to have any problems, as the box multiply by the original width and height and so on and so forth. So for the x min is going to be width, also for the x height, and y min the height, and from the definition it's 3, 4, 5 and 6, right, which is up here. We don't care about the 7th one. There's a missing bracket there. Right, so we're done. But now what we do is, it would be nice to also add a label, and ideally we need to place the label below, I prefer below the person, because in most cases you won't be able to see the top. So let's put in a location 20, but this should be not be static, should be pretty much dynamic. So let's call it y max. So let's take the maximum of y and add the location if y max and the location are greater than location, or else it's gonna be all over the show. Else y max should be less minus location. Alright, cool. So there's where our label is gonna be situated. So now, as I mentioned before, our model for the face masks outputs a floating number, which is from -1 to 1, where -1 it's no mask and 1 it's with mask. So now we need to get that output. So it returns a nested numpy array, and we need to flatten that nested numpy array so that we only get one output. And it would be nice to work with rounded decimals. Let's round it over to 3 decimal points, and let's call it detected thresh. Right? Yeah. Now obviously this if we're just plotting this, it's going to be all over the show. So let's also add a threshold. So let's say if detected is greater than or equals to our defined, no, it's going to be too much. Let's just say 0.5 for now, 50%, and the label should say mask, right? Mask, yeah, wearing a mask, yeah, wearing a mask. I can't even type. Wearing a mask, and this should give a different color scenario. It would be nice to have a different color scenario, and we know that in this case it's BGR, so it's blue, green, red. So it should be mask, green, and red for no mask. So there you go. Else it's the opposite. So no, not wearing mask, and this should be red. Should be red. Let's format this quickly. Black. Somewhere it's not happy. Let's find this 131. Did you want? Oh, there it was. There we go. Saved. So after the label, we need to add the bounding box, the rectangle around the face, and in order to do that, we call in CV2 OpenCV2 and rectangle. So this adds a rectangle around the frame with our x min and y min. It's our starting point for our rectangle, and our ending point for our rectangle, which will be x max and y max. And depending on the label, as we defined it, we're gonna take the color, the label, it should be either blue or green, and the size should be just 1. Also, it would be nice to add some text so around the image saying that detected face and so on and so forth. So this takes in frame, the label of the frame. Let's give it label of the frame, which is the first element there. Where should the label be placed? Let's just call it x min minus 2 times location. So that's for our x, and our y. That these are just values that I thumbsucked before. It was nice to place them there. And depending on the font, I prefer CV2 font, Ashi Simplex. This is much cleaner. And for the font scale, just give it 0.5 because we don't want to hog the whole screen. And the color, depending on the label, should be determined by mask or no mask. And the thickness of the text, make it 2. Cool, that's good. Let's format. Okay, looks nice. And after all is done, it should just return the frame. Alright, cool. So we have a bounding box, we got our output frame, but it would be nice to debug it and see. I remember we passed in an argument called debug, and we can access it. So let's just say if the debug is true, let's show the image show, right? And call it frame. And which image do we show? We show the frame. And we want to be able to exit anytime that we want by hitting Q. And in order to do that, just say key CV needs to wait key, and mask that with hexadecimal 255. And if the key that is pressed is equals to hexadecimal number of Q, we have for quit, then it should break out of the while loop. And once it's done, we need to release the stream to show that okay, we've broken off. Release the stream and clear up all the other windows. Destroy all windows. And that's it. So what we've done is pretty much code up this short face mask detection, which takes in arguments and passes it into the inference stream, and then pretty much straightforward. Yeah, so now that we've coded it up, it's probably a good time to test it. I do not have OpenVINO installed as mentioned, so I use my Docker Docker container, and as I've shown you, defined face detection. We need to run it in Docker container since I don't have Intel OpenVINO installed on my Ubuntu 20.04. I have it all installed in a Docker container, which you can pull. Cool. I'll run it again. Let's see how it goes. Alright, cool. We see I'm not wearing a mask. Let's see when she wears a mask what it's gonna say. Wearing a mask, and also it did change the bounding box to green. I think that's happy. So she is wearing a mask. So let's exit this with Q. Let's try a different resource. Let's try a different video. Because that was an N95 mask, let's try with a cotton mask. And let's see if it's gonna be able to pick that. I don't know why it didn't pick up that, but we can see that it's picking here, even though she's facing away from the camera. It's saying not wearing a mask, so we know that the facial detection can work 100%. And you can see her face, she's not wearing a mask. And there's a cotton mask. She's putting on the mask. Turn on. Let's see. Let's try and guess. So yeah, she's wearing a mask. So I think this brings the end of this tutorial. Thing that I noticed with the face detection model is that it doesn't work 100%. Sometimes it detects, sometimes it doesn't. It can't detect more than 2 people. So I'm still trying to work around that. Hopefully I'm gonna try not to train my own model. I'm gonna have to just find other models online and then just convert them using the model optimizer. I'm able to use them here. But yeah, thank you for watching and hope to see you soon. Don't forget to subscribe and like.